All right, in this video, I'm going to try and go through 3 word problems for you. The first problem being a mixture problem. So I'm going to look at example 6 in your book and you can follow along with me. The manual of your new car uses gasoline that's 89 octane. In order to save money, you decide to use some 87 octane and 93 octane in combination with the 89 octane currently in your tank in order to have an approximate 89 octane mixture. I wouldn't do this in real life. Anyways, assuming you have 1 gallon of 89 remaining in your tank, and your tank is a capacity of 16 gallons, how many gallons of the 87 and 93 should you use to fill up your tank to make a mix of 87 or 89 octane? So the first thing I do is when I make these problems, I do a chart. And I do solution 1, solution 2, and the mix. I do percent of whatever it is we have, and the amount of whatever it is we have, and the total. In this case, it would be percent octane. So I know I am mixing, let's see here, I'm trying to make an 89 mix, and I'm mixing 93 and 87 together. And I know my car is a 16-gallon tank, but I already have 1 gallon of exactly what I need. So we're just going to forget that 1 gallon and say that I'm mixing only 15 gallons together. So the question is, how many gallons of each? Well, I don't know how many gallons of this, so I'm going to call that X. And this one would be whatever remains of that 15 gallons that's not X. So it'd be 15, take out the X. To get my total, I would multiply across. I'm going to get 93X. And then 87 times 15, which is 1305 minus 87x. And then I have to take 89 times 15 to get 1335 for my total mix. Maybe it's common sense that to mix these together means I'm adding them together. So 93x plus 1305 minus 87x is 1335. Sorry, I'm doing the work out loud. I get 6x equals what? 30. X is 5. So the nice thing about a chart is that it organized my information. I know that the X I solve for is the number of gallons of 93 octane. So I can say 5 gallons of 93 octane. And let's see, what's 15 minus 5? That would be 10 gallons of the 87 octane. And then I can look and see, yippee skippy, I got it right. Where am I looking? Here we go. 10 gallons of 87 and 5 gallons of 93. If I were you, I would try the your turn problem next and look in the margin to the side will be the answer. Press pause here and try this. All right, hopefully you have now done it and the answer is right here. Answer. All right, let's try another kind of problem. We have a distance rate problem. So usually this would be a current problem or a wind problem. In this case, it takes 8 hours to fly, so we're talking wind. It takes 8 hours to fly from Orlando to London, which is 9.5 hours, and 9.5 hours to return. So again, I'm going to make a chart, and I'm going to say with wind and against wind. So with wind and against the wind. And we know that distance equals rate times time. Those are the bits of information I'll have. That's not very nice writing. Okay, so let me go back to my problem here. It takes 8 hours and it takes 9.5 on the return. So 8 hours is quicker than 9.5. So 8 hours must be with the wind and 9.5 hours must be coming back. And then it says, where am I? If an airplane on average is 550 miles per hour in still air, so that's not with the wind. So my rate would be 550 miles per hour plus the wind. And if I'm going against the wind, it's going to be 550 minus the wind. Same deal here. When I do distance, I'm going to multiply across. So this would be 8 times 550 plus W. And this would be 9.5 times 550 minus W. And if you go somewhere and then you come back from there, you've gone the same distance both times. So you're going to set these distances equal to each other and solve the problem. And so that's what they did, let's see here, right here. And that's how they worked it out. And then you're solving for the wind. And again, if I were you, I would try the your turn, problem next, press pause. And then there's your answer. One more kind of problem we should do is a work rate problem. So let's talk through this one really quickly. When we're talking about a rate, we are talking about parts per whole. No, sorry, I got a text. A rate is miles per hour. In this case, it's jobs per hour. So Connie can clean her house in 2 hours. So that means that Connie can do 1 job in 2 hours. And then who is this other person? This other person who helps her, they can clean the house in 1 hour and 15 minutes together. So the question is, how long is he going to take working by himself? So Connie plus this other person who can do 1 job and we don't know how long. But if they work together, if we add them together, they could do 1 job in 1 hour and 15 minutes. So that would be 1.25, and I hate putting decimals inside fractions. So that's really 1 over 1 and 1/4, also known as 1 over 5/4. So 1 divided by 5/4 is really 4/5. So I'm going to go back over here and rewrite this. 1/2 plus 1 over x is 4/5. We good on that? 1.25 is 1 1/4. That's 5/4. 1 divided by 5/4 is 4/5. And now we're back to the first section. I'm going to multiply this by my common denominator, 10x. So I get 5x plus 10 equals 2x times 4, which is 8x. 3x is 10. So apparently by himself, he takes 10 divided by 3, also known as 3 1/3 hours. So that would be what? 3 hours and 1/3 of an hour would be what? 20 minutes? 3 hours and 20 minutes. And look at that. I got it right.